Hello. In this video, I want to look at how to convert whole equations from polar to rectangular or vice versa. We know how to take a single point and convert it, but what about a whole formula? So we're going to rely on the same conversion formulas that we have shown on the screen, and we will work with plugging them into an equation instead of like a single point. So first, convert y equals x squared into polar coordinates. So the process we're going to do here is we know what y equals in polar. It's r sine theta, so we're going to replace it. We know what x is. It is r cosine theta, so we're going to replace it. Squared. And then we'll simplify a little, so r sine theta equals r squared cosine squared. And we want to simplify and solve for r. And so I'm going to move the cosine theta over, the cosine squared theta, and I'll move the r over. So I have r squared divided by r. So I move the r over and the cosine over. Now we can simplify that a little. Sine theta over cosine squared theta. I can think of that as sine theta over cosine theta times 1 over cosine theta equals r. And that, let's flip it around, r equals, what's sine over cosine? Well, you know that that is just tangent. And then 1 over cosine? Well, that's just secant theta. So there, to graph a parabola in polar equations, you're going to do tan theta times secant theta. So sometimes you're a little creative when you're doing these conversions. It's not always straightforward. And you have to know your trigonometry pretty well to have success with it. Let's try the second one. Convert x squared plus y squared equals 4 into polar coordinates. So what we did last time was we switched x for r cosine theta and the y for r sine theta. And we can continue to do that. And we would simplify that and we'd eventually get the answer. Or, let's be smart. What do we know that x squared plus y squared equals? Bingo. It already equals r squared. So r squared equals 4. Square root both sides. R equals 2. Boom, you've done. So a circle in polar coordinates is just r equals some number. And then that number is the radius of the circle. So if I were to graph this, it would be a circle with a radius of 2. And we already know that based on what we know of x squared plus y squared equals 4. We should know that formula in rectangular already. What about a straight line? Y equals x. What is that in polar coordinates? Y equals r sine theta and x equals r cosine theta. So for this one now, let's move over. If I divide r cosine theta, the r's cancel out, leaving me sine theta over cosine theta. On the right side, I have equals 1. So this is interesting. Sine over cosine is tangent theta. So I have the equation tangent theta equals 1. But this time, I'm actually going to take tan inverse of both sides. Tangent inverse, tangent inverse. And what is tan inverse of 1? It is pi over 4. So you see that theta equals pi over 4 is the equation of a normal line in polar coordinates. So just like in rectangular, if you're doing a vertical line, it's x equals whatever number that vertical line is at. So you kind of only rely on one variable. Same thing in polar, but this time when you rely on one variable, the theta, it creates that straight line. When you rely on one variable, the r, it creates that circle. And then 2 more equations here, and these can be a little more difficult. We're converting polar into rectangular. So r equals 4 sine theta. If I can get an r squared in here, that's going to be good. So what I'm going to do is multiply both sides by r. So that's a step you sort of have to think of yourself. So good thing we can introduce it here right now. Because now I have r squared. What does r squared equal? it equals x squared plus y squared. And there you go. And then I have 4r sine theta. You know what r sine theta is. That's just y. So I have this equation x squared plus y squared equals 4y. And then to know what to do next might be kind of difficult. You see the x squared and the y squared, so you think this is a circle, but then you have the 4y and you're like, not sure what to do. Well, we are going to subtract that 4y over, and then we complete the square on this portion right there. So if I complete the square on y squared minus 4y, I'm going to take that negative 4, divide by 2, and then square that, so that equals 4. So I need to add 4 to both sides in order to complete the square, and that's going to create a perfect square trinomial. So add 4 to both sides of the equation, and now I'm going to factor the y squared minus 4y plus 4, factors as y minus 2 squared, and there you go. You hopefully can recognize this as the equation of a circle with its center at 0, 2, and then a radius of 2, because 2 squared is 4. So you have to be kind of creative sometimes when doing these conversions. In fact, we're going to be extra creative in this next one. Convert r squared equals sine 2 theta into rectangular. Sine 2 theta, do you recognize that trigonometric formula, that trigonometric identity? It equals 2 sine theta cosine theta. So I convert that, but then when I see the sine and cosine, when I'm trying to convert, I never really want just a sine or just a cosine. I want it to be paired with an r. So I'm going to multiply by r, and that gives me 2r sine theta, cosine theta. So now my sine has a partner r, but I still need another one for cosine. So I'm going to multiply by r again, and that gives me 2r sine theta, and I'll put that r now next to cosine, the second one I multiplied by. And now I can flip these. What is r squared? It's x squared plus y squared. And what is r squared? It's x squared plus y squared, the same thing, equals 2 times r sine theta, that's y, and r cosine theta is x. So I can write this one last time, x squared plus y squared squared equals 2xy. And this one doesn't really have a great way to solve it, so we'll just leave it like this. And if you're to graph this, here is the shape it creates. It's called a lemniscate, except it's symmetrical, so let's see if I can draw that. Still not great, but it's that slanted infinity symbol. The equation in rectangular coordinates is kind of confusing. X squared plus y squared squared equals 2 times xy. Something you don't really see. But in polar coordinates, it's pretty simple, pretty straightforward. R squared equals sine 2 theta. Not too crazy in order to get, well, what I think is a kind of crazy looking graph, this slanted infinity symbol. So it's cool how polar coordinates can create those interesting looking graphs in a very simple way. So I hope this helped to convert whole equations. You use the same conversion formulas. It's just sometimes you have to be pretty smart, pretty tricky in order to coerce the equation to be in the right form. And a lot of times that involves multiplying both sides by r, maybe once, maybe twice.